Alright, let's go. Number 10. Sacsayhuamán. In 1533, Spanish conquistador Pedro Sancho de la Hoz stood on a hillside above the city of Cusco in the Peruvian Andes and wrote something in his journal that his superiors back in Spain would struggle to believe. He had seen the walls. Sacsayhuamán sits on a ridge overlooking Cusco at an elevation of approximately 3,700 meters above sea level. Its outer walls stretch for nearly 400 meters. They are constructed from limestone and andesite blocks, some weighing in excess of 200 tons. The largest single stone in the complex has been estimated at 360 tons, roughly the weight of 50 fully loaded semi-trucks stacked together. Sancho de la Hoz wrote that neither the Bridge of Segovia nor any other construction he had ever seen could compare to what the Inca had built on that hillside. He was a man who had seen the architecture of Renaissance Europe. He said this anyway. The walls are built in a zigzag pattern of 3 ascending terraces. The joints between the stones are so precise that a sheet of paper cannot be inserted between them. No mortar was used. The stones hold each other in place through geometric interlocking, each block shaped to fit its neighbors with tolerances measured in fractions of a millimeter. The blocks were quarried from sites located between 15 and 35 kilometers away. The terrain between the quarries and the construction site includes steep river valleys, unstable hillsides, and elevation changes that would challenge modern heavy equipment. The Inca had no iron tools, no wheeled vehicles, no draft animals capable of pulling loads of that magnitude. What they had was stone, rope, human labor, and a method of moving and shaping 200-ton blocks across mountainous terrain that no engineer has fully reconstructed. Experimental archaeology has attempted to replicate Inca construction techniques using wooden sledges, earthen ramps, and coordinated teams of workers. The largest stones successfully moved by these methods weighed approximately 40 tons. The effort required hundreds of people working in precise coordination across days of continuous labor. The stones at Sacsayhuamán are 5 times heavier. The truly disturbing aspect is not the weight. It is the precision. Moving a 200-ton block across 35 kilometers of Andean terrain is an engineering problem that can theoretically be solved with enough labor and time. Shaping the block to fit against its neighbors with sub-millimeter accuracy, without iron tools, without the ability to measure or mark the stone with modern instruments, is a different category of problem entirely. Modern stonemasons given modern tools have attempted to replicate the joint tolerances found at Sacsayhuamán. The results consistently fall short. The fits achieved by contemporary craftsmen using steel chisels, angle grinders, and precision measuring equipment do not match what anonymous Inca laborers produced in the 15th century using stone and bronze. The Spanish believed it was built by demons. That explanation has been discarded. No satisfying replacement has been offered. Number 9. Puma Punku. On the Bolivian Altiplano, at an elevation of 3,800 meters, approximately 70 kilometers west of La Paz, a field of shattered stone blocks covers several acres of high-altitude plateau. The site is called Puma Punku. It is part of the larger Teotihuacan complex, a civilization that flourished in the Lake Titicaca Basin for approximately 1,000 years before collapsing around 1000 CE. What makes Puma Punku different from every other ancient construction site on Earth is not the size of the stones, though some weigh over 130 tons and were transported from quarries 90 kilometers away. It is not the elevation, though building anything in nearly 4,000 meters above sea level with pre-industrial technology presents its own nightmarish challenges. It is the cuts. The blocks at Puma Punku display machining characteristics that should not exist in a pre-Columbian context. Flat surfaces ground to tolerances of less than half a millimeter. Right angles so precise they require optical instruments to verify. H-shaped interlocking blocks carved with interior channels, recesses, and drill holes that exhibit a consistency of depth and diameter impossible to achieve with stone or copper tools. One particular block, sometimes called the H block, contains a series of precisely spaced drill holes along an interior channel. The holes are uniform in diameter. The spacing between them is identical. The channel itself runs at a perfect right angle to the block face. The surface finish inside the channel is smoother than the exterior surface of the block. To achieve these characteristics using hand tools, a craftsman would need to grind the interior of a channel in hard andesite by hand to a surface quality finer than the exterior, maintaining perfect angular relationships throughout, while working at altitude with tools that leave no trace in the archaeological record. Geologist David Childress and engineer Christopher Dunn independently examined blocks from Puma Punku, and both concluded that the manufacturing characteristics are more consistent with machine tooling than hand craftsmanship. Their conclusions are controversial. They lack institutional backing, and no machining technology has been identified at the site. What has been identified is this: the Teotihuacan civilization had no writing system. No evidence of advanced mathematics in any surviving form. No iron metallurgy. The only tools recovered from the site are stone hammers and copper chisels that leave visible marks inconsistent with the surface finishes found on the most precisely worked blocks. The truly unsettling aspect of Puma Punku is the combination. Not just the precision, not just the transportation of 130-ton blocks across 90 kilometers of altiplano, but both together, executed by a civilization that left almost no record of how they did either. The site was partially dismantled by later cultures, who used the blocks as building material. What remains is a scattered field of engineered stone, sitting in the wind at 3,800 meters, waiting for an explanation that has not arrived. Number 8. The Trilithon of Baalbek. In the Bekaa Valley of modern Lebanon, at a site that has been continuously occupied for at least 9,000 years, 3 stones sit in the western retaining wall of a Roman temple complex and quietly destroy the conventional history of ancient construction. The Temple of Jupiter at Baalbek was built by Roman engineers during the 1st and 2nd centuries CE. It was one of the largest temple complexes in the Roman world. The Romans were master builders. Their engineering capabilities are well documented. They left behind aqueducts, amphitheaters, roads, and bridges that have survived 2 millennia. But the Romans did not build the foundation their temple rests on. The Trilithon consists of 3 limestone blocks incorporated into the western wall at a height of approximately 8 meters above ground level. Each block is approximately 19 meters long, 4 meters tall, and 3.5 meters wide. Each one weighs approximately 800 tons. The Romans, whose engineering records are extraordinarily detailed, left no record of building the Trilithon. No inscription. No account. No documentation of the workforce, the method, or the timeline. The blocks appear in the foundation as if they were already there when Roman construction began, because they were. In a nearby quarry, a 4th block called the Stone of the Pregnant Woman sits partially cut from the bedrock. It was never moved. It weighs an estimated 1,000 tons. Beside it, archaeologists in 2014 discovered an even larger unfinished block weighing approximately 1,650 tons. It remains in the quarry where an unknown civilization began cutting it, and then, for reasons that left no record, stopped. Whoever quarried these stones intended to move a 1,650-ton block of limestone to a construction site. The destination was never reached. The project was simply abandoned, mid-cut, in the rock. The truly disturbing aspect is the silence. The Romans documented everything. The Greeks before them documented everything. The Phoenicians who occupied the site before the Greeks left written records. Nobody claimed the Trilithon. No culture identified itself as the builder. The largest cut stones in human history sit in a valley in Lebanon without an author, without a method, and without any surviving evidence of how they were placed. Number 7. The Great Pyramid of Giza. On August 12, 2023, a team of researchers from Scan Pyramids published updated internal mapping results from their ongoing muon tomography survey of the Great Pyramid of Khufu. They had found another void. This was not the first. In 2017, the same team identified a large previously unknown cavity above the Grand Gallery, the first major interior discovery at Giza in over a century. The 2023 results suggested additional uncharted spaces within the pyramid's core. The Great Pyramid has been studied continuously for 4,500 years. It remains incompletely understood. The standard account is familiar. Built by Pharaoh Khufu around 2560 BCE. Constructed from approximately 2.3 million stone blocks. Average block weight between 2.5 and 15 tons, with granite blocks in the king's chamber weighing up to 80 tons transported from quarries at Aswan, 800 kilometers to the south. The standard account leaves several things unexplained. The pyramid's base covers 53,000 square meters. The maximum deviation in the levelness of that base is 2.1 centimeters across the entire footprint. Ancient Egyptian surveyors laid out a foundation covering more than 5 hectares to an accuracy of 2 centimeters without laser levels, without GPS, without any instrument more sophisticated than plumb bobs, sighting rods, and set squares. The 4 sides of the pyramid are oriented to true north, south, east, and west with an average deviation of 3.6 arc minutes. The most precisely oriented building constructed in the modern era, the Paris Observatory, is oriented to within 6 arc minutes. The Great Pyramid is more accurately aligned than a structure built with modern surveying instruments. The casing stones that originally covered the exterior, most of which were removed in the medieval period for building material, were finished to tolerances of 0.01 millimeters. The mortar between them was applied in a layer so thin that the joints are nearly invisible despite the enormous weight pressing down on them. Engineer Chris Dunn calculated that building the pyramid in the 20-year reign attributed to Khufu would have required placing one 2.5-ton block every 2 minutes, continuously, for 2 decades, including nights and through every season. At current construction wages and material costs, replicating the Great Pyramid today would cost an estimated $5 billion using modern equipment. It has never been attempted because the logistical challenge remains genuinely daunting even with cranes, trucks, and power tools. The truly disturbing aspect is not any single characteristic. It is the convergence, the alignment precision, the foundation levelness, the casing stone tolerances, the internal geometry that maintains dimensional accuracy through 2.3 million blocks stacked 146 meters high. Any one of these achievements would be remarkable. Together, in a structure built 4,500 years ago, they describe a level of engineering mastery whose source we have not fully identified. What we know is this: someone built it. The Egyptians almost certainly built it. And the methods they used to achieve tolerances that challenge modern construction have not been conclusively demonstrated by any experimental archaeology program yet conducted. Number 6. Nan Madol. On a coral reef off the eastern shore of Pohnpei Island in the Federated States of Micronesia, a city built on artificial islands rises from the shallow lagoon. Nan Madol consists of 92 artificial islets constructed from interlocking basalt columns. The columns, each weighing between 5 and 50 tons, were quarried from a site on the opposite side of the island, transported across open ocean, and stacked without mortar into walls reaching 7.5 meters in height. The total volume of basalt moved to construct Nan Madol is estimated at 750,000 metric tons. The site has no freshwater source. It has no agricultural land. It cannot support its own population. Every person who lived there, worked there, and built their required food and fresh water transported from the main island by canoe. The construction is dated to approximately 1200 CE, built by a dynasty called the Sotolur, who ruled Pompeii for an estimated 500 years before being overthrown. But oral traditions on the island describe the construction as beginning far earlier. Local legend holds that two sorcerer brothers named Olisipa and Olasopa arrived from a place called Katau, used magic to fly the basalt columns into position, and founded the city in a period before recorded history. The archaeology and the legend share one common problem. Neither explains how 750,000 metric tons of basalt columns were transported across open ocean water to a coral reef with no beach, no natural harbor, and no land connection to the quarry site. Experimental attempts to move the basalt columns using traditional Micronesian watercraft have succeeded with small sections under calm conditions. Scaling those results to the full construction volume, accounting for the weather patterns of the Western Pacific, produces numbers that strain the capacity of any pre-industrial civilization even given centuries of continuous effort. UNESCO designated Nan Madol a World Heritage Site in 2016. The designation noted the site's outstanding universal value and its continued archaeological mystery in the same document. The truly disturbing detail is what lies beneath it. Sonar surveys of the lagoon floor around the artificial islands have produced anomalous readings suggesting structural features beneath the waterline. What those features are, whether natural reef formations or something constructed below the visible city, has not been definitively investigated. A city built on water, on an island with no resources, by a dynasty whose origins are unknown, may have a foundation that extends below the surface of the lagoon. What it rests on has not been fully measured.